Right now, deep beneath the Pacific Ocean off the coast of Oregon and northern California, geologists have uncovered evidence of something that could redefine the earthquake threat facing the entire American West Coast. For over 2 decades, marine geologist Chris Goldfinger and his team at Oregon State University have been drilling sediment cores from the ocean floor at a place called the Mendocino Triple Junction, where 2 of the most dangerous fault systems in North America meet. And what they have found is unsettling. Layered deposits buried in the sediment show that at least 3 times in the last 1,500 years, a massive earthquake on the Cascadia subduction zone was followed within minutes to hours by another major earthquake on the San Andreas Fault, not decades apart. Not years apart, minutes to hours. Scientists are now warning that if these 2 fault systems are capable of triggering each other, the true worst-case scenario for the West Coast is not 1 catastrophic earthquake. It may be 2, striking almost simultaneously, hundreds of miles apart, overwhelming every emergency system in their path at the exact same time. This is not normal news cycle noise. Something genuinely alarming has been sitting in the geologic record for over 300 years, and scientists only just found the pattern connecting it. No guessing, no dramatizing, just the facts, the science, and the real stakes. Drop a comment right now. Have you ever felt an earthquake, even a small one? Tell me where you were and what it felt like. Thousands of you have shared stories about swaying buildings and shaking floors in past videos, and I always love reading those. If you want to be the first to know every time this story develops, subscribe to the channel right now. It is completely free. A thumbs up also helps enormously. Let us go for 5,000 likes on this one so the algorithm actually shows it to people who need to see it. Thank you. Now, let us get into it. To understand why this discovery matters, you first need to understand the 2 fault systems involved, because they are fundamentally different from each other, and that difference is exactly what makes a connection between them so alarming. The Cascadia subduction zone runs roughly 700 miles along the Pacific coast, from Vancouver Island in Canada down through Washington, Oregon, and into northern California. Along this line, the Juan de Fuca and Gorda tectonic plates are being forced underneath the much larger North American plate, in a slow, grinding process called subduction. When enough pressure builds up and the locked section of the fault finally slips, it does not produce an ordinary earthquake. It produces a megathrust earthquake, magnitude 9 or greater, capable of unleashing violent, sustained shaking that lasts for minutes, along with tsunamis that can strike the coast within 20 minutes of the initial rupture. Geologists estimate this kind of event happens roughly once every 400 to 600 years along Cascadia. The last confirmed one struck in the year 1700. An earthquake so powerful it sent a tsunami all the way across the Pacific Ocean to Japan. Where it appears in historical records as an orphan tsunami, a wave with no earthquake felt locally to explain it, because the earthquake that caused it happened thousands of miles away, off the coast of Oregon. Then, starting south of Cape Mendocino in California, an entirely different type of fault begins. The San Andreas Fault is not a subduction zone. It is a strike-slip fault, where the Pacific Plate and the North American Plate are grinding sideways past each other rather than one sliding underneath the other. This is the fault responsible for the devastating 1906 San Francisco earthquake, and the segment of it capable of producing the most damaging quakes ruptures on a shorter cycle, roughly once every 200 to 300 years. For decades, seismologists studied Cascadia and the San Andreas as 2 separate hazards, run by separate physics, on separate timelines, that simply happened to sit near each other on a map. This new research suggests that assumption may be wrong. Here is how the discovery actually happened, and the story itself is almost accidental. Back in 1999, Goldfinger and his research team set out on an ocean research cruise with a very specific goal to collect sediment cores from within the Cascadia subduction zone in order to study the timing of ancient megathrust earthquakes. But a navigational error took the ship off course roughly 55 miles south of Cape Mendocino, directly into San Andreas Fault territory. Rather than treat it as a wasted detour, the team decided to drill a core there anyway. What they pulled up from the seafloor did not look like a typical Cascadia sample. Underwater sediment layers called turbidites, formed by landslides that are frequently triggered by earthquakes, normally settle in a predictable pattern. Coarse, heavier sand at the bottom, and finer, lighter silt on top, because heavier particles sink and settle first. But this particular core showed the reverse, coarse sand sitting on top of fine silt. That inverted structure, which the researchers began calling doublets, was the first clue that something unusual had happened at that exact location. 2 closely spaced earthquakes on 2 different fault systems, essentially stacked on top of each other in the geologic record. That one strange core sat as an open question for years. It took over 2 decades of additional drilling, ultimately gathering more than 130 sediment cores, representing roughly 3,000 years of geological history along both fault systems, before the pattern became clear enough to publish. When the team compared the timing and internal structure of turbidite layers from the Cascadia zone against those from the San Andreas zone, they found the same doublet pattern showing up again and again. Radiocarbon dating on the layers confirmed that in at least 3 separate instances over the past 1,500 years, including the well-documented 1700 rupture, the 2 earthquakes were not simply close together on a geological timescale. They were close together on a human timescale, separated by minutes to hours, not years. Now, let us understand exactly why that timing is the single most important detail in this entire story. An earthquake happening on the Cascadia zone once every few centuries is a known planned for risk. An earthquake happening on the San Andreas Fault once every few centuries is also a known planned for risk. Emergency response systems up and down the West Coast, from Seattle to San Francisco, are built around the assumption that these are largely independent events, meaning if one strikes, resources from unaffected regions can be mobilized to help. That assumption is the entire foundation of coordinated disaster response. But if a Cascadia megathrust earthquake can directly trigger a San Andreas rupture within the same afternoon, that foundation collapses. As Goldfinger himself put it, researchers have spent years treating the Cascadia Big One as the ultimate nightmare scenario for the region. This new evidence suggests that scenario may not actually be the worst case. The true worst case is a chain reaction, a magnitude 9 megathrust off the Pacific Northwest coast, followed within hours by a major rupture along Northern California's San Andreas segment, striking a coastline that stretches nearly the entire length of the continental United States' western edge, all while the first earthquake's emergency response is still being organized. This discovery does not exist in isolation either. Separate research published earlier this year identified something else unsettling happening beneath Northern California right now. A complex, hidden network of tiny earthquakes, far too weak for anyone to actually feel, clustered in a zone scientists are still working to fully map. On their own, these microtremors are not considered dangerous, but their existence confirms that the crust beneath Northern California, precisely the region where Cascadia and the San Andreas meet, is significantly more structurally active and complicated than earlier models assumed. 2 independent lines of research, one looking backward 3,000 years into the sediment record, one looking at present-day seismic activity, are both pointing toward the same conclusion. This junction is more dynamic, more interconnected, and less predictable than scientists believed even a few years ago. So let us be honest about what this discovery does and does not mean, because overstating it helps nobody. This research does not predict when the next Cascadia earthquake will happen. It does not claim every future Cascadia rupture will automatically trigger a San Andreas earthquake. Out of the roughly 19 Cascadia earthquakes identified in the sediment record over the past several thousand years, researchers found evidence of this doublet pattern in only 3 instances. That means, based on the current data, a triggered San Andreas rupture appears to be a possible outcome of a major Cascadia earthquake, not a guaranteed one. Scientists studying the connection are careful to describe this as raising the probability of a coast-wide disaster scenario, not confirming it as the default outcome. The honest scientific position is this: we now have solid physical evidence that these 2 fault systems are capable of interacting in a way we did not fully appreciate before, and that possibility needs to be built into how the entire West Coast plans for its worst-case earthquake scenario going forward. Let us talk about what a combined rupture would actually look like, because understanding the stakes here matters. A magnitude 9 Cascadia megathrust earthquake alone is already one of the most destructive natural disasters the United States could face. With the U.S. Geological Survey and FEMA planning documents describing potential outcomes, including the near total loss of transportation infrastructure west of Interstate 5 in parts of Oregon and Washington. Tsunami waves reaching the coast in under 20 minutes, a disruption to lifeline infrastructure, power, water, and communications that could take months to fully restore in the hardest hit coastal communities. Layer a major San Andreas rupture on top of that, striking Northern California within the same day, and the emergency response calculus changes entirely. The National Guard units, medical teams, and mutual aid resources that California would normally send north to help Oregon and Washington, or that Oregon and Washington would send south to help California, would instead be needed in both places simultaneously. This is precisely the scenario Goldfinger flagged as the genuinely new and concerning finding, not a bigger single earthquake, but a double disaster with no reserve capacity to draw from. Let us be direct about the practical message here, because information without action is just anxiety. If you live anywhere along the Pacific coast, from British Columbia down through Northern California, this research does not change what you should already be doing to prepare. It simply reinforces why that preparation matters. Know your evacuation route to higher ground if you are in a tsunami inundation zone, something you can check in about 5 minutes using your state or county's official tsunami hazard map. Keep a basic emergency kit with water, food, and medication for at least a week, since this research specifically raises the possibility that outside help may be slower to arrive than previously planned for. If you live further south in the San Francisco Bay Area or along the San Andreas corridor, understand that your region's earthquake risk is no longer being evaluated purely on its own timeline. It is now being studied in relation to activity hundreds of miles north. None of this requires panic. It requires the same thing every major seismic hazard requires: understanding your specific local risk, having a basic plan in place, and trusting the scientists who spend their careers studying exactly this question. Final thought: the San Andreas Fault and the Cascadia subduction zone have existed side by side for millions of years. Two of the most closely watched fault systems on the planet, and for decades, scientists studied them as separate stories with separate endings. It took a navigational mistake on a research ship in 1999 and over 20 years of painstaking work analyzing more than 130 sediment cores to reveal that their stories may, at least sometimes, be the same story. 3 times in the last 1,500 years, the geologic record suggests these two giants moved together, minutes to hours apart, in a sequence capable of striking nearly the entire length of the West Coast within a single day. Whether that pattern repeats the next time Cascadia ruptures is a question no scientist can answer yet. What has changed is that the question is now being asked seriously, built into hazard models, and treated as a real possibility rather than a footnote. The instruments are drilling deeper, the sediment cores keep getting reanalyzed, and every new core pulled from that stretch of ocean floor adds one more data point to a 3,000-year story that is still being pieced together in real time. We will keep tracking this as it develops, every new study out of Oregon State, every fresh survey of that hidden fault network beneath Northern California, every update to the region's official hazard planning. Subscribe so you do not miss updates on any of it, and leave that comment below. Have you ever felt an earthquake? Tell me what it was like. Because this is not just a story about rocks and sediment. It is a story about millions of people living on top of a system scientists are only now beginning to fully understand. Understanding that is how we stay motivated to take this seriously. 5,000 likes on this video. Let us go. See you in the next one.